Hello. In my first video, I showed you how to create a spreadsheet that would calculate fret locations based upon 1 divided by the 12th root of 2. Traditionally, guitar makers have used the so-called rule of 18, simply because in the days before calculators, working out a ratio like this is very difficult to do. Let's see how using the rule of 18 affects string distances as calculated by the spreadsheet. Here is the exact ratio, 1 divided by the 12th root of 2. The rule of 18 in this case will be 17 divided by 18, and that gives me this fraction here, 0.944 recurring. And the error between this ratio and the exact ratio is about 600 parts per million, or about 0.6%. We'll put this ratio into the spreadsheet and see how it affects the fret locations. As you can see, 35.4 millimeters is the exact location, 35 millimeters is the approximate location based on this ratio, so it's about 0.4 millimeters different, which doesn't look too bad. But as you move down the fingerboard, you start to see anything up to 2.4 millimeters difference. In other words, this fret here is going to be 2.4 millimeters further back than it should be, so your string, the playing length of the string, will be 2.4 millimeters longer than it should be. And that will be quite audible if you happen to be playing with other people. So is there a better ratio that we can use? There is. The first thing I'm going to do is multiply each of these numbers by 100 to give me 1700 over 1800. And unsurprisingly, that gives me exactly the same ratio. I'm now going to make just one change. Literally just one change. 1700 over 1801. And you can see here that the error has dropped by an order of magnitude. If we compare the actual fractions, 943, 943. The fourth decimal varies by just 1. This is a pretty good approximation. We'll try that in the spreadsheet. You can now see that the biggest error we've got is just 0.2 of a millimeter. That represents about half the width of the slot that you're going to cut with a fret saw. I add one more decimal to these values. It doesn't change them a great deal. Is there a better approximation again? The answer is yes, although I would say that it's fairly pointless using it, but we'll go through it anyway. Our even more accurate approximation is 1749 divided by 1853. As you can see, 0.943874, 0.943874. This is accurate to just 0.5 parts in a million, or as a percentage, 0.001%. If I add an extra decimal, 0.0005%, which is pretty good. Let's put that in. Now the difference between the exact location and the approximate location is so small it doesn't even show up at 2 decimal places. I have to add yet another decimal place to see anything. And to get a sense of how big these numbers actually are, I have to add yet another decimal place. I'll put these numbers into some kind of context. that number there, 0.0003 of a millimeter, if that was light, that would be somewhere in the ultraviolet. That would be somewhere in the visible spectrum, and that would be in the infrared. In other words, if I've got two lines that are separated by just this distance, which is about 600 nanometers, I would not be able to see the difference between those two lines under a light microscope. Remember, you're cutting slots using a steel rule and a fret saw. The reason I say it's pointless using this ratio is in part because of the differences. We don't need to worry about nanometers difference. And the other reason is simply, why are you remembering 8 digits, dividing one number by another, and then getting a number that is only accurate to about 7 digits? Why don't you just remember 8 digits? 1, 2, 3, 4, 5, 6, 7, 8. So if you're going to use an approximation to 1 over the 12th root of 2, I'd suggest you keep your calculations nice and simple and just put in 1700 over 1801. You don't have to, but I think in practical terms it's not going to make any meaningful difference to how accurately you cut the frets, because by far and away the biggest error is going to be your personal error using a steel rule, a fret saw, and a pair of eyes. Thanks for watching.